Yes, dear students, in the previous class, we studied about the concept of hydrides. What are hydrides? Hydrides are the binary compounds when dihydrogen gas reacts with all other elements except noble gases are called hydrides. Hydrides can be classified into three types, namely ionic hydrides or saline hydrides, covalent hydrides and metallic hydrides. Okay, what are ionic hydrides or saline hydrides? When dihydrogen gas reacts with only S block elements like alkali metals and alkaline earth metals to form a hydrides are called ionic hydrides or saline hydrides. Give an example for ionic hydrides. Give an example for ionic hydrides. Okay. For example, NaH, sodium hydride, magnesium hydride, MgH2, calcium hydride are the examples for ionic hydrides. Okay. The next one is covalent hydrides. What are covalent hydrides? Covalent hydrides nothing but when dihydrogen gas reacts with only p block elements except noble gases. For example, NH3, CH4, H2O, BH3 are the examples for covalent hydrides. Covalent hydrides can further classified into three types, namely electron deficient hydrides, electron deficient, electron precise and electron rich hydrides. What are electron deficient hydrides? When dihydrogen gas reacts with only group 13 elements, to form a hydrides are called electron deficient hydrides. Give an example: BH3, AlH3, etc. are the examples for electron deficient hydrides. What are electron precise hydrides? When dihydrogen gas reacts with only group 14 elements to form a hydrides are called electron precise hydrides. For example, CH4, methane, SiH4, silicon tetrahydride are the examples for electron precise or electron sufficient hydrides. What are electron rich hydrides? When dihydrogen gas reacts with group 15 to group 18th elements, group 15 to group 17 elements, group 15 to group 17th elements to form a hydrides are called electron rich hydrides. For example, NH3, H2O, HF, hydrogen fluoride, etc. are the examples for electron rich hydrides. And the last one is metallic hydrides. When dihydrogen gas reacts with D and F block elements or transition elements and inner transition elements. Transition elements are and inner transition elements to form a hydrides are called metallic hydrides. Metallic hydrides are also known as non-stoichiometric hydrides. Give an example for metallic hydrides. Titanium hydride, zirconium hydride, lanthanum hydride, titanium hydride are the examples for lanthanum hydride, titanium hydride, zirconium hydride are the examples for metallic hydrides. These are the some important classification of hydrides. Important classification of hydrides. Okay. And the next concept is water. Okay. What is the molecular formula of water? H2O. The next compound of hydrogen is water. The molecular formula of water is H2O and its molecular mass is 18 U. Unified mass or 18 gram. Water is a very important compound for the survival of living beings. Okay. It can exist 65% in human body. 65% in human body and 95% of water present in plants. What is the percentage of water present in plants? 95% and in human beings 65%. Okay. Water is distributed in different forms of the earth surface. For example, oceans, ice glaciers, lakes, groundwater, river water, soil moisture, atmospheric moisture are the important sources of water. Water is distributed different types in the surface of the earth. For example, oceans, ice glaciers, river water, atmospheric water, soil moisture. These are the some important sources of water. Structure of water. The next concept is structure of water. Structure of water. The water molecule which can undergoes sp3 hybridization. sp3 hybridization. sp3 hybridization. And the shape of the molecule based on hybridization is tetrahedral and the bond angle is 109 degree 28 minute. But due to the presence of lone pair electrons present in oxygen, for example, oxygen, hydrogen, atomic number of oxygen is 8, electronic configuration 1s2, 2s2, 2p4. Only 2 electrons to involve the bond formation. Remaining 4 electrons do not involve the bond formation in oxygen atom. So, 2 lone pair electrons and 2 bond pair electrons present in water molecule. The central atom of the water molecule is oxygen. Due to the presence of lone pair and bond pair repulsion, the shape of the molecule is distorted based on VSEPR theory. The shape of the water molecule is V shape or bend shape. And the bond angle is reduces 104 degree, 104.5 degree because due to the presence of lone pair and bond pair repulsion. Water is a colorless, tasteless or odorless liquid. H2O molecule is always exist in liquid state because due to the presence of hydrogen bonding. Hydrogen bonding present in water molecule is always exist in liquid state. and its boiling point is 100 degrees Celsius or 373 Kelvin temperature, and the freezing point of the water molecule is 0 degree or 273 Kelvin. 273 Kelvin. These are the important physical properties of water. And the next one is the crystalline form of water is ice. The crystalline form of water is ice. Ice is with highly ordered three-dimensional hydrogen bonded structure. Ice is three-dimensional hydrogen bonded structure. Three-dimensional hydrogen bonded structure, and due to extensive hydrogen bonding extended in three-dimensional direction, and even a small space present inside the ice, hence density of ice is lower than water. Hence ice floats on the water surface. The crystalline form of water is ice. Ice is a three-dimensional orderly hydrogen bonded structure with the density of ice is lower than water. Hence ice floats on the water surface. What are the important chemical properties of water? Chemical properties of water. Chemical properties of water. The first one is amphoteric nature. Amphoteric nature or amphiprotic nature. Water which can behave both acidic as well as basic in nature. For example, here NH3 aqueous treated with H2O molecule aqueous give rise to. In this chemical reaction, NH3 acts as a base, water molecule acts as an acid. Based on Lowry and Bronsted theory, an acid is a proton donor. And base is a proton acceptor. NH4 plus. This is the base. This is the acid. Conjugate acid. This is conjugate base. Okay. In this chemical reaction, water molecule which can behave as acidic in nature. Another one example, HCl aqueous is treated with H2O molecule. Give rise to. In this chemical reaction, hydrochloric acid which can behave as an acidic in nature, and the water molecule which can behave as basic in nature. An acid is a proton donor Cl minus, and base is a proton abstractor or acceptor H3O plus. This is acid, this is conjugate base. This is base, this is conjugate acid. What do you mean by conjugate acid base pair? A pair of an acid and base which differ by one proton is called conjugate acid base pair. These two chemical reactions shows water molecule which can behave as both acidic and basic property. Hence this nature which can shows the effect of amphoteric property or amphiprotic property. In the first reaction, water molecule which can behave as an acid, and the second equation, water molecule which can behave as a base. And the next one is redox reaction. Redox reaction with water. Redox reaction with water. What do you mean by redox reaction? Both oxidation and reduction reaction takes place simultaneously during the chemical reaction is called redox reaction. For example, here sodium metal is treated with water molecule which gives NaOH, sodium hydroxide and hydrogen gas. Sodium hydroxide and hydrogen gas. What is the oxidation state of sodium? 0. Oxidation state of oxygen is -2 and oxidation state of hydrogen is +1. Oxidation state of sodium is +1, oxygen -2 +1. The oxidation state of hydrogen is 0. 0 to +1 +1 to 0. Here 0 to +1 increase in the oxidation, nothing but oxidation and +1 to 0 decrease in the oxidation state is called reduction. Both oxidation and reduction reaction takes place simultaneously during the chemical reaction. This type of reaction is called redox reaction. In this molecule, water molecule shows redox property. Okay.